This lesson is on probability. So we just talked about empirical probability or experimental probability or the probability in the long run. And it's because of the law of large numbers that we're able to actually look at what the theoretical probability would be. So we did a test, and from our stoplight example, 35 out of 100 times we got a green light. So even though I wasn't there when they programmed the green and yellow and red, I'm assuming that they've programmed it to be 35% of the time green. Now, what is important is we need to understand some of the rules of probability. And the more that you understand these rules, the easier this lesson will be. So rule number one is the value of a probability. Probability is the chance of something occurring. So that falls between 0 and 1. If you get a probability of 0, that means it certainly will not occur. If you get a probability of 1, that means it certainly will occur. So notice the way that I've written it. That just means 0 is less than or equal to the probability is less than or equal to 1. Keep in mind that typically we're going to write these as decimals as opposed to percentages. So instead of 100%, we would write it as 1. Instead of 0%, we would just write it as 0. Something like 50%, I would write as 0.5. So turning percents back into decimals. You can't have a negative probability, so I can't have a negative chance of winning a game, and even though it's great to say we're going to give 110%, it's really impossible because you can only give 100%. So again, probabilities are written as decimals. So if you have a 50% chance of flipping heads, we would say, notice the way that I'm writing this. P heads, which means the probability of heads equals 0.5. This notation is going to be very important to us moving forward. We talked a little bit about this when we were finding z-scores and probabilities. We said the probability that z is greater than 2.4, and then we used our calculator to calculate that. But it's important that we understand that this is just talking about find the probability. So that's rule number one, is that probability comes between 0 and 1. Rule number two is the sum of the sample space, which means if I added up all of the different probabilities, it needs to add up to 1. So there's a 100% chance that I'll roll a 1, 2, 3, 4, 5, or 6. To roll a 1, I have a 1 in 6 chance. To roll a 2, I have a 1 in 6 chance, blah, 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 all the way out to 6. And if I add those up, that's 6 out of 6, or 1. So no matter what we have going on, whether or not they're equal probabilities or not equal, we know that total, the probability is equal to 1. Our next rule, rule 3, is the complement rule, and this really piggybacks off of the rule that we just talked about that says that the sample space is equal to 1. So the complement of a probability is the probability of the event not occurring. So for instance, the probability of rolling a 2 is 1 out of 6 on a regular die. The probability of not 2, which sometimes they write like this, or as you can see, sometimes they write like this, okay? Or sometimes they'll even put a little squiggle, the probability of not 2, would be 1 minus 1/6 or 5/6, because there's 5 sides of the dice that are not a 2. So that's what's called a complement. So in our stoplight example, the probability of green was 0.35. So the probability that I didn't get a green was 1 minus 0.35, which is 0.65. So again, this would be like the 0.35 for getting a green. This, all the stuff on the outside, is the stuff that's not green. So 0.65 that I get either a red or a yellow. The next rule has to do with the addition rule. And we're going to talk about the addition rule and the multiplication rule, and then we're going to talk about the general addition rule, which is a little bit better than this one, and then the general multiplication rule. But what you need to understand in this video is that the addition rule occurs when there's just one event but multiple outcomes that we would be satisfied with. One event but multiple outcomes. So let's say I'm going to roll a die. That's one event. The outcomes I would be satisfied with are any of the even numbers. Okay, so that would be more than one thing could occur and I'm still satisfied with it. So again, I want these events, in order to use the addition rule, not general, but the addition rule, they have to be disjoint. And here's what that means. Disjoint means that one outcome couldn't fall into more than one category. For instance, if you're a freshman in college, then you can't be a sophomore in college. Or if you're a sophomore in college, then you can't be a freshman. You're one or the other. Something where they're not disjoint would be things like, say I'm drawing a card and I want to find the probability of a king or the probability of a red. Well, there are reds that are kings or kings that are red, whatever. So these are not disjoint, and so we couldn't use this particular rule for finding that probability until I show you the general addition rule. So more to come on this later. For now, we're only looking at disjoint events. For instance, what's the probability of rolling a 4 or a 2? If I do a Venn diagram, and notice this doesn't look like a Venn diagram we normally use. Normally Venns look like this, but notice in this I've got some overlap. Here there's no overlap because I can't roll both a 1 and a 2 at the same time. So this is my Venn for rolling a die. The probability of rolling a 4 or a 2, I want you to notice the way I'm going to write it. So I have the probability of 4 union 2. This means or. So the probability of rolling a 4 or a 2, again, one event occurring, which means I'm just finding the probability of each and adding them together. So 1/6 plus 1/6, which is 2/6, which is a third, which of course I would write as a decimal. A lot of students ask, how many decimal places should I go to? 3 at a minimum. 3 or 4 is a really good bet. If you go to 2, you're going to probably end up with a lot of errors. Typically, if you're doing something in the middle of a question, I would go to 4 places and then round to 3 at the end. I want you to notice that as I was solving this, however, I didn't turn this into 0.167 and 0.167, because then when I added them together, I might have made a miscalculation. So if you have them in fraction form and it's easy to add them in fraction form, go ahead and do that. I want to show you a couple of examples before we talk about multiplication rule, a couple of examples where we use rule 4. In this case, I'm actually using the addition rule, which is rule 4, and the complement rule, which I believe is rule 3. Using our stoplight example where probability of green was 0.35, and now they're giving us that the probability of getting a yellow is 0.04. And I want to find the probability of a red. So the first thing I'm going to do is I'm going to use the addition rule. I'm going to find the probability of yellow union green. Okay, find the probability of both of those, which means I'm adding the probabilities of yellow, which is 0.04, plus the probability of green, which is 0.35, and I'm adding them together to get 0.39. Now I want to find the probability of red, so this is where the complement rule comes in. I know that there are only 3 options. There's red, yellow, and green. If there's more than that, then there's something wrong with the light, I think. So these are my options, which means the probability of a red light would be equal to 1 minus the probability of yellow union green, because yellow union green is the probability of not red. Okay, so 1 minus this probability would be 1 minus 0.39, which would be 0.61. So that would be my probability. Again, one more example before we move on to the multiplication rule. I want you to know when to look for errors or what to look for in errors. So here's 2 situations where we've made an error. So if you would pause your video right now, look at both of these situations and see if you can find the error before I go through them with you. Okay, hopefully you've taken a chance to look at those questions. The first one, again, we're talking about college. We're saying the probability of a freshman, sophomore, junior, and senior are, and then they give me all of those probabilities. So what's wrong with that? Well, we know that if you're in college, you're one of those 4 classes. We're going to keep the non-traditional, non-degree seeking students out of it. So essentially, you're one of those things. And then the probability of that needs to add up to 1, and if I added all of those up, I don't get 1. So that's the problem with the first one. For the second one, I've got probability of owning a smartphone equals 0.5, and probability of owning a computer is 0.9. And if I add those up, I get 1.4. So what did I do wrong? Did I add wrong? Did I make a miscalculation somewhere? No, the problem here is that they are not disjoint, meaning It's possible that I own both a smartphone, which I do, and a computer, which I do. So this doesn't work with the rule that we're using so far for addition. This is where we'll have to use the general addition rule, which I've put in a different video for you. Last one on this video, last rule, is the multiplication rule. And when we did the addition rule, remember it was just one event occurring. So this is the probability of 2 or more events. So that's when we use multiplication, is when we have more than one event going on. The probability here is found by an and it's multiplying those probabilities together. So the probability that I got A and I got B. So what's the probability of rolling a 2 and a 4? Again, that would mean first find the probability of rolling a 2, which is 1/6, and then find the probability of rolling a 4, which is 1/6. And again, I'm just going to multiply those together because the first time I got a 2 and the second time I got a 4. And that gives me 1/36, and then notice it's a decimal again. So again, just a couple of keywords for you. If you see or, that means one event is occurring. You're going to add the probabilities. If you see and, that means 2 or more events are occurring and we're multiplying the probabilities. If we see not, that's subtract from 1 or find the complement. And then at least, that's the complement of none. And here's what that means. If I said, find the probability of at least 1 red in a deck of cards. Well, that would mean that's 1 minus the probability of no reds in a deck of cards. That's what we'll do. So this we're actually going to use quite a bit.